is this guy? This guy is going to be infinity and then times infinity. So yeah, and then that will be infinity. Not a problem here. All the cases which you see right here, they're the easy case. Now what is example 9? Limit of 3 over x as x goes to infinity. So that will be 3 over infinity. What is 3 over infinity? Can you tell me what that is?
Infinity? No.
No, 3 over infinity is not infinity. This means 3 over the very large positive number at the bottom now. So we have 3, and then we have, sorry, not 3. What this means is we have x here, and we have 3 over x. And now we want to make this x go big and big forever. So this guy is going to go to infinity. We'll get in large and large and for large forever. So if this x equals 10, so what do you get? Well, this will become 0.3. But 10 is obviously not a high number. So now, how about if you now plug in 1,000?
It's approaching
then
0.
We get 003. Okay, so we get that. But is 1,000 a large number? Not quite. So should I really pick a big number? What is my big number? What is the number I choose? The number I choose is this. 10 to the 1,000 power. Really big now. Okay. But this guy's still not infinity though. It's still not infinity. Now when you put, what is this guy? Well, this now becomes, what, 3 times 10 to the 1 minus 1,000. Well, now we can see what's going on. This is a very tiny positive number. So now we can answer, where is this going to? This is heading to 0.
0.
But I'm going to call this guy 0 plus. So this one is what? It's going to be 0 plus. And then I'm going to write equal to 0. And 0 plus is actually useful. But the final answer is actually 0. If you give me the right final answer 0 plus, I will accept that, however. But if you write 0, that's okay. I'll accept that one. Your textbook will accept 0. Your textbooks, most instructors, most textbooks, they will not accept 0 plus as a final answer. They will accept 0, okay? But if you put 0 plus, that's roughly right, okay? So I'm not going to bother you too much there. Now, let's look at example 10. Minus infinity. 3 over minus infinity, what do you think this will be? 0 minus. But this will also be 0 eventually. Final answer is still 0. If you write 0 minus, I will kind of accept that, okay? But 0 is the official answer to get this. Now let's look at example 11. What is this? Oh, this one. What is that? 3 over infinity. 3 over 0 plus, so that will be infinity. And the plus 7, that will be infinity. And then the denominator is 0 plus. What is that? A very large positive number and then plus 7 over a very tiny positive number. What is that? Can you tell what this is?
Infinity?
That's right, that would be infinity. And what is this guy? This guy is 0 minus here. And then 3 over x squared, x over 0, this will be plus infinity. And then plus 7. What is this guy here? Now, all of you are experts at this now. The answer is minus infinity. Minus 0 minus is a negative positive, a very number which is so close to 0, which is a negative number. Okay, so let me save this. And now what I like to do is, now we get into this. Indeterminate forms. You know what? Unfortunately, we only have 10 minutes to go, right? And we didn't even have a break here. But you know what? Most of the stuff we can actually do this. Okay, so you know what? Tomorrow's test, we will still have a test tomorrow, and it will be you'll have to take the test at 8 a.m. And I am going to only test you on whatever I cover today. You know, maybe a little bit of tomorrow, but no, there's no class tomorrow. So whatever I cover today will be on tomorrow's test. Okay. So whatever I cover, I guess I'm not going to cover section 1.6. Okay, so now let's look at example still here. What is this here? Now indeterminate forms in calculus 1. Now these are what we call the indeterminate forms in calculus 1. When you go to calculus 2, they have indeterminate forms too. They will have what we call the exponential indeterminate forms. So let me just make some comments here. I know that I don't have that much time, but let me just make it anyway. In calc 2, of course, this is Calc 1, so we are not going to cover Calc 2. In Calc 2, they have more indeterminate forms, and they will get into forms like this. They will get into forms like, what is it? Let's see. 1 to the infinity power, how about 0 to the 0 power, and then they have what they call a 0, and then what to 1 raised to infinity power, and anyway, it goes on, okay? And there are a lot of forms like there. But mostly exponential indeterminate forms, which are obviously more complicated, okay? So that's that. But in this class, in Calc 1, these are the only 4 indeterminate forms we will cover in this class. Only 4 forms. And we have already seen this guy 0 over 0. This is one of those 4 kinds. You have only these kinds. So you have to worry about these kinds. If it's not this, then the answer is then it's over. So let me exactly explain to you now. What does this indeterminate form mean? Indeterminate form means that we don't know the answer yet. Don't know yet. What do you know? We don't know the answer. Now this is not the same as undefined. Undefined means there's no answer and that's it. Game is over. Game is over, there's no answer. No answer is a final answer. Is that clear? No answer means that's the final answer. There is no number. And that's the final answer. Indeterminate form means we don't know the answer yet. We didn't do the problem yet. That's what it means. So when you get an indeterminate form, what does it mean? Work harder. So what does an indeterminate form really mean? It means that the many results were, this is what it really means. Not cannot determine. Not determined, many results are possible. So now let me show you example 13, 14, 15, 16, 17. All of these are indeterminate. They're all 0 over 0 indeterminate forms. So when you plug in, you get 0 over 0. But let's see what we have here. This is going to be now the limit of, this time, let's simplify. X upwards is 0. And then when you simplify this, you get x. Oh. So what is the limit of x as x goes to 0? Oh, that is 0. So the answer is 0. Well, you could not plug in x equals 0 initially, but you have to simplify this and you get 0. That is a 0 over 0 form. But in this case, the final answer came out to be 0. Now let's look at example 14. Oh, this is something we have seen before. Yeah, we have seen this before actually. Limit h is up with 0. Again, this is also a 0 over 0 form. In fact, all of these examples here are 0 over 0 form, all 5 examples. So what is this? This is h. And then now this 2h, and then 2h, this is now what? H, 2h, and then plus h. Yeah, we have actually seen this form. And now what is it now? The limit, 0 over 0. Now we have to reduce the h's here. So let h up for 0. And when you reduce h here, what we do is we get 2 plus h. And then what happens here? Oh, we get the answer 2. So what I'm trying to say is, this is a 0 over 0 form. In example 13, the answer came out to be 0. In example 14, this is also 0 over 0. But we get a different result. Indeterminate form means that many results are possible. That's what we want. It means that we have to work harder. Indeterminate form is never an answer to any problem. Is that clear? Again, the indeterminate form is never an answer to any problem. So if you tell me that something is indeterminate form, then I know how many points I need to give you. I will just give you 0. All right? That's clear. If you say that something is an indeterminate form, all I need to do is just give you 0 points. That's it. So now let's look at example 15. What is this guy? Example 15, limit x to the opposite what? 1. And then 1, what is this? This is now going to be now 0. So now 7 over x minus 1 squared. What is that? This is going to be 0 over 7 over x upwards to 1 plus or minus, but there's a square here. So that guy is 0 plus. Because it is actually 1 plus or minus, and then minus 1 square. So this guy will be either 0 plus or 0 1, but we have a square, so we get a 0 plus. Because when you square, a number that will become a plus. Final answer is what? Is infinity. Example 15 is also 0 over 0 form. So when you have a 0, 0 over 0 form, it's an indeterminate form. What does the indeterminate form mean? Indeterminate form means many results are possible. it means that you have to work harder. It means that we don't know the answer. It means indeterminate or no yet. That's what it means. And this guy here is actually what? The limit of 7 over x minus 1 and x approaching 1. Oh, now in this case, looks like we have to split. This is actually does not exist. Because when you split this, you can see you have to split this. 1 is going to be x approaching 1 plus, and then the other one is going to be x approaching 1 minus. And then you can see that one side is infinity, while the other side is minus infinity. The answer does not exist. Now, what's this guy here? Oh, this guy we have, you know what? This guy you can just do this by factoring. This is also 0 over 0. X approaching 1. So what is this? This is x minus 1, and then times x minus 1 times x plus 1. And then the numerator in this case is going to be, we have x minus 1. And then you are going to get a long polynomial here. Anyway, you do this, all right? I'm not going to, I'll let you do this on your own. Okay, so what I'm going to do is I'm going to, that's that, and that's that. Okay, so let me, you know what, let me see, should I just take okay, so let me save this, and then clear. So now let me go here. Infinity of infinity form. That's the indeterminate form as well. Now let me just do one. This one, we simplify this, so cannot plug it in. X approaching what? 0. What is that going to be? Well, that will actually be x. Now the whole thing will actually become x. When you outside b, it's x. And then, oh, this will be 0. So we have an infinity of infinity form, but we got 0 in this case. It approaches 0. Now what is this? This is also infinity of infinity form. So you plug in infinity, but infinity of infinity indeterminate cannot plug in. You have to go by indeterminate form. That means you cannot substitute. Cannot substitute here directly. Cannot substitute substitute at that form. At that form. So you have to change the form. So now, what is example 19? What is that equal to? The example 19 limit here. What is this? This is now equal to 5 over 5x, or 5x. If you simplify that, you get 5x. X out to infinity. Oh, so what is the answer now? 5. Oh, this one is easy, infinity. Now this one here. Limit, example 20, limit of 3x squared minus x minus 8 plus 8 over x squared plus 100x. Note that this is also infinity of infinity form. Right? This is also infinity over infinity form. So in this case, how do you do this? Let me show you how we do this. It's going to be this. The limit, x approaching minus infinity, and then what? This is what we do. Now, this is a special case now. This is actually a third technique. The third technique in evaluating limits is involving infinity, and this is what we do. We are now going to multiply this here, the same thing you copy here and there, and then you know what? We are going to multiply top and the bottom by 1 over x squared. This is the third technique. The first technique was factoring. The other technique, second technique, was multiplying by conjugates, either square root conjugates or cube root conjugates. And now this is a third technique. We only have 3 techniques. This is the last of the 3 techniques of evaluating limits. Is this. So when you do that, 1 over x squared, where's the x squared coming from? The degree of the denominator is actually degree 2. So that's where this x squared is coming from. The degree of the denominator is 2. So we multiply by 1 over x squared, 1 over x squared. So if we do that, so it looks like, class, this will be our last example. It looks like our test is going to cover up to this example. Okay, so this x approaching what? It's x approaching minus infinity. So now, if you multiply this, okay, so here we have 3x squared. I guess I have to write this out. But this will be a last example, and yeah, thank you for your patience. But let me just finish the example, okay? So with this, and then we have what? X squared, and then what? Minus, so is it plus minus 100? Plus 100. Plus, looks like it's going to be 1 over 100. 100? 100x. Oh, this one we didn't multiply. Okay, so now this. So now when you multiply all that, you know what we get? We get 3 minus 1 over x, and then plus 8 over x squared. And so the expression looks rather complicated, right? But it's going to be simplified very fast. This is plus 100 over x. So when you have an infinity limit or a minus infinity limit, then this is what you do. This is the technique, the third technique we apply when we have a limit of a rational function, infinite limit of a rational function. Then this is what we do. And the square here, what is this 2 here? This 2 is actually the denominator, is the degree of the denominator. Okay, so that's right. Now, when you do that, so what do you get? We actually get 3, and then minus 0, plus 0. Oh, it's not a 6, it's 0. And then this is 1, and then plus 0. See, with x approaching minus infinity, what is this guy going to? It could be 0 plus or minus, but you know what? At this point, we don't care. It doesn't really matter. Because we have a 3 here. So the final answer comes out to be 3. This is 0. This is actually 0 minus. But it's 0. 0 minus is still 0. And we have a 1 here. And because you have 1 here, 1 plus 0 minus is still 1 plus 0 is 3. Final answer is 3 in this case. So now what I'm saying is, infinity over infinity, why is it an indeterminate form? Because in one times we get 0. In the other case, we get the infinity. And here we get 3. And you know what? It could also be any other number, by the way. It could be any other number. Okay, so you know what? To prepare for tomorrow's test, I think a good idea is for you to actually what? Just continue studying here, and it will be a good exercise. Okay, so anyway, up to here. And again, let me mention about the test. So test midterm 2, not midterm 2, midterm 1 tomorrow from 8 a.m. to to 11 a.m. Okay. The testing time limit will either be, I don't know, somewhere between about 2.5 hours or 3 hours. I'll look at it. I have not written the test yet, so okay. And so and then no Zoom lecture tomorrow. No Zoom lecture. There will be no class, but you have to take the test tomorrow. No Zoom lecture tomorrow. So I will see you. Meet you on Thursday. All right? Okay, so the class is over. All of you, thank you for your patience. And I will have to pay back the break time, which we didn't have today. Okay, so all of you have a good day, and I will meet you on Thursday. Everybody will be taking the test at 8 a.m. tomorrow. So there's no window time, okay? So
I have a question, Professor.
Yes, what is the question?
So for number 20, that's you said it could be 3 or any other number. So basically that's infinity, right? It's positive infinity.
The answer is, you mean example? You're talking about example 20?
Yes.
Example 20. So. Again, what is your question again? I couldn't exactly understand your question.
Is the answer technically infinity? Because you said it could be 3 or any other number. So does that mean it's positive
So
infinity?
Example 20, the answer is 3. What I'm saying is, if you have a limit which is infinity over infinity form, if you have this form, then
right.
You cannot figure out what the answer could be. But for example 20, for this particular example, the answer is 3. I don't know. Did I make it?
No. Oh, okay. I do understand.
So what I'm saying is, if you have a limit and then it's infinity, then you cannot figure out what the answer will be yet. So you have to work on. But every specific problem will have an answer. That's what I'm saying. But infinity, there's no answer. You cannot figure out what the answer is. That's going by indeterminate form. So example 11, if you look at example 18, this guy is infinity of infinity too. Infinity of infinity. In fact, this guy is plus infinity, and the top is going to be plus or minus infinity. So we don't know exactly what this could be. But it turns out the answer is actually 0.
Okay.
Or let's say if I give you, let's say like this, limit of, let's say x is approaching infinity, I can give you one more example, a very simple example. The answer, let's say example, this is example limit 3x over 4x. Maybe I should have included this one too, but we have done enough examples. Now this guy is also infinity of infinity. But in this case, when you actually simplify this and reduce the x's, so what do you get? We actually get 3 over 4. Oh, the answer is 3 over 4. In this case, all the x's are gone. The answer is actually 3 over 4. So in this case,
I see.
But that's 3 over 4. Every limit has only one answer. The answer cannot be 3 and infinity. Okay, that doesn't make any sense. But what I'm saying is, the limit with these forms, everybody has different answers. That's what I'm saying. But if you have a sum like infinity over 3, that is, it doesn't matter what kind of infinity. This will always be infinity. So that is not an indeterminate form. And if you have infinity plus infinity, something going to infinity plus another going to infinity, and then what is that? That will always be infinity. However, infinity minus infinity, that's different. Infinity minus infinity is an indeterminate form. Infinity plus infinity is plus infinity, but infinity minus infinity is an indeterminate form. In fact, that's the last kind. Infinity minus infinity, this is the fourth kind. The most difficult infinity in calculus 1 is this guy. But unfortunately, we have no time to go over that guy. The last kind of the indeterminate form in this class is infinity minus infinity, because we don't know who the big guy is. This guy is infinity bigger, or this guy is bigger?
Right.
Because, you know what? If you go down the page on this file, then you will see infinity minus infinity, and then on that section, you can see. Okay, you can see. So I think one way to study for these limits, do you know what it is? Actually, is to just continue studying this page, to continue studying this section, and then you will actually learn a lot. Okay, that's one way to study. Just before.
Thank you so much.
Very good.
Hi, Dr. Lee.
Yes.
I've sent you a message in the chat.
Okay. Yeah. So, right now I don't know. Okay, I'm going to check the answer as soon as I'm done with it. Okay.
Okay. Thank you so much.
Let me see. Where is the chat? Oh, right here. Oh yeah. Sure.
Thank you.
I already put a note, so I will. Yeah, sure. I'll do that.
Thanks a lot.
Yes. Okay.
So when we're doing
But by the way, Summer.
Yes.
But you still have to, start the test at 8 o'clock. You know that, right?
Yes.
So can you start at 8? Oh, now the question is this: or can you do that, or what is your basic, schedule? I mean, after 11. I mean, is it okay? 8? You can start at 8.
Yeah. Mm-hmm.
Okay. All right. Okay. Then no problem. Okay. Then that's done. Okay.
Thank you.
No problem. I'll do that.
Hi, Professor. I have 2 questions for you.
Oh, sure. Okay. So let me get ready here. Okay. So should I get to whiteboard? Okay. So let me first hear. Listen to your question. So what is your question?
Okay. First one. What would you say is the time difference for it? Right now, the current time for this quiz, this midterm, won't be a problem for me. But last time, I'm still under the same time difference, and I was up to, it was a 9-hour time difference. So would that constitute, if I could get an extension for future midterm, just in case if it happens? I'll be back on the 20th.
Okay, so let me first of all, where is it too personal if I ask you where you are?
No, it's not. I'm in France.
You're in France. Okay, I see. So what is so right now the time is 11 a.m. here, LA 11 a.m. So what is your local time?
Right now, I believe it is 8 p.m.
8 p.m. I see. So if the test is from 8 a.m. till 11 a.m., then your time will be from 5 p.m. to 8 a.m. Yes.
Yeah, that part I'm not talking about this midterm. This midterm's fine because the way you did it, this works well for me. I'm saying last time, it was late in last time, the last midterm, when the class could take it. I want to say it just went a little bit bad. I had a bad schedule conflict, but in the future, if there is something like a serious time difference, do we approach you and just give you a warning beforehand?
Yeah. In that case, usually what I do is I will extend the time. That's usually what I do, so that everybody will. So when I have to do something for, if one person has a problem, in your case, or it's too inconvenient, then what I like to do is I can extend the time a little bit more. So in your case, our class is from 8 a.m. till 11 a.m. So your time is from 5 p.m. to 8 p.m. So in this case, if I give you a 12-hour window, would that work in any case? What was the window of time in local time for that 10 hours I gave you? What was their time window in local time?
I have to remember. I have to check the Canvas thing. I just wanted to make sure that in the future, if there was an issue, I could approach you beforehand.
Okay. So what I'm doing is, after this, I might actually, ask everybody to fill out like a questionnaire, and I call that a quiz, a personal quiz, and it's a personal quiz. It's not a MATLAB quiz. And so one of the questions I ask there is actually where you are in the time zone. And so I will look at it. Every semester I have somebody like you who is somewhere in a very far from LA, and their time zone is kind of weird. But you are required to attend that class meeting. But if the test is outside the time zone, then usually I give about 10 hours.